Hello everyone. Statistics. Statistics is the study of the collection, organization, analysis, interpretation, and presentation of data. It deals with all aspects of this, including the planning of data collection in terms of the design. So, today we are going to discuss something more related to this topic, statistics. The first subtopic is mean. The mean is the average of the numbers, a calculated central value of a set of numbers. There are three methods to calculate out mean, and these are the first one, the direct method, that is x bar is equal to summation of fi xi upon summation of fi. The next one is the assumed mean method, that is x bar is equal to a plus summation of fi di upon summation of fi. The next one is the step deviation method, that is x bar is equal to a plus in the brackets summation of fi multiplied by ui upon summation of fi closing the bracket multiplied by h. Limitations and uses of mean. The disadvantage of the mean. The major disadvantage which does not occur is the fact that a mean can be dramatically affected by outliers in the set. For example, we find the mean of the set of numbers 1, 2, 3, 4, 5, we get 3. However, when we dramatically alter one number in the set and find the average again, the mean is quite different. For example, 1, 2, 3, 4, 20 has a mean of 6. Uses. The mean to describe the middle of a set of data that does not have an outlier. Example. A class teacher has the following absentee record of 40 students of a class for the whole term. Find the number of days a student was absent. Below is a table shown. Solution. To find the class mark of each interval, the following relation is used. The formula states xi is equal to upper class limit plus lower class limit divided by 2. Taking 17 as assumed mean A, di and fi di are calculated as follows. From the table, we obtain summation of fi is equal to 40, summation of fi di is equal to minus 181. So, mean is equal to x bar is equal to a plus in the bracket summation of fi di upon summation of fi. That is equal to 17 plus in the bracket minus 81 divided by 40. That is equal to 17 minus 4.525. That is equal to 12.475. That is equal to 12.48. Therefore, the mean number of days is 12.48 days for which a student was absent. The next subtopic is mode. The mode is the value that occurs most often. If no number is repeated, then there is no mode for the list. Mode is equal to L plus in the bracket f1 minus f0 divided by 2f1 minus f0 minus f2 closing the bracket multiplied by h. Limitation and uses of mode. Limitation. could be very far from the actual middle of the data. The least reliable way to find the middle or average of the data. Uses: the mode when the data is non-numeric or when asked to choose the most popular item. Example: the given distribution shows the number of runs scored by some top batsmen of the world in one-day international cricket matches. Find the mode of the data. Solution: from the given data, it can be observed that the maximum class frequency is 18, belonging to class interval 4000 till 5000. Therefore, model class is equal to 4000 till 5000. Lower limit L of model class is equal to 4000. Frequency F1 of model class is equal to 18. Frequency F0 of class preceding model class is equal to 4. Frequency F2 of class succeeding model class is equal to 9. Class size H is equal to 1000. Substituting all the values in the formula of mode, we get 4000 plus in the bracket 14,000 divided by 2.3, which is equal to 4000 plus 608.695, which is equal to 4608.695. Therefore, mode of given data is 4608.7 run. The next subtopic is median. The median is the middle value in the list of numbers. To find the median, your numbers have to be listed in numerical order, so you have to rewrite your list first. Median is equal to L plus in the bracket n upon 2 minus Cf upon f close the bracket multiplied by h. Limitation: if the gap between some numbers is large while it is small between other numbers in the data, this can cause the median to be a very inaccurate way to find the middle of a set of values. Uses: the median to describe the middle of a set of data that does not have an outlier. Example: an life insurance agent found the following data for distribution of ages of 100 policyholders. Calculate the median age. If policies are given only to persons having age 18 years onwards but less than 60 years. Look at the table carefully. Solution: your class width is not the same. There is no requirement of adjusting the frequencies according to class intervals. The given frequency table is of less than type represented with upper class limits. The policies were given only to persons with age 18 years onwards, but less than 60 years. Therefore, the class intervals with their respective cumulative frequency can be defined as below. From the table, it can be observed that n is equal to 100. Cumulative frequency just greater than is 78, belonging to interval 35 to 40. So, n divided by 2 in the bracket, that is 100 upon 2 is equal to 50, closing the bracket. Therefore, median class is equal to 35 till 40. The lower limit L of the median class is equal to 35. Class size H is equal to 5. Frequency F of median class is equal to 33. Cumulative frequency of class preceding median class is equal to 45. Substituting the values in the median formula, giving us 35 plus 25 divided by 33, which is equal to 35.76. Therefore, the median age is 35.76. Now let us discuss cumulative frequency curve, also known as Ogive. This is a curve drawn by plotting the value of the first class on a graph. The next plot is the sum of the first and the second values. The third plot is the sum of the first, second and third values, and so on. Example: during medical checkup of 35 students of a class, their weights were recorded as follows. Draw a less than type Ogive for the given data. Hence, obtain the median weight from the graph. Verify the result by using the formula. Here is a graph of upper class limits versus cumulative frequency. Here n is equal to 35, so it is 17.5. Mark the point A, whose coordinate is 17.5 and its x-coordinate is 46.5. Therefore, the median of this data is 46.5. After marking the points, we have the graph as follows. It can be observed that the difference between two consecutive upper class limits is 2. The class marks with their respective frequencies are obtained as follows. We have the table as follows. The cumulative frequency just greater than n upon 2, that is 35 by 2 is equal to 17.5 is 28, belonging to the class interval 46 till 48. Median class is equal to 46 minus 48. Lower class limit L of the median class is equal to 46. Frequency F of median class is equal to 14. Cumulative frequency CF of class preceding median class is equal to 14. Class size H is equal to 2. Substituting the values in the formula, we get 46 plus in the bracket 17.5 minus 14, the whole thing divided by 14, closing the bracket multiplied by 2, is equal to 46 plus 3.5 divided by 7, which is equal to 46.5. Therefore, median of this data is 46.5. Hence, the value of median is verified. So this was all about our lesson statistics. Learning about this is important as it is used to monitor and improve the quality of products and process within business organization. Also, for the development of social science theories being used to test their validity through the real world data. Thank you, students.